Hello everyone. With this small tutorial, I wanted to show you about how to do PC to bot ZigBee communication. This is kind of part one, so we'll use a manager tool only. Later, we'll do part two where we'll use Visual C to do that job. So let's get on with it. So the topics are discussing ZigBee communication between PC and CM510 or CM530. You will need a USB 2 dynamic mixer, which is this part, the ZigBee serial module, which is here, and the ZigBee100 daughter card that sits on top here. So the real thing looks like that. If you happen to have one of those older computers that have a 9-pin serial port, you can hook up directly up to this point. You don't need to buy the USB 2 dynamic mixer. But the USB 2 dynamic mixer have other things that you can do it for too, but so that's another time. We'll be using the ROBOTIS Tool Manager. We use a small little TestZigBee program on the robot side. So ZigBee100 have 3 mode of operation: 1-to-1, waiting, they call waiting, or many-to-1, and broadcast. So today we'll be using broadcast only today. And these mode settings can be done via the manager tool or the PC terminal tools. We use the manager tool today. When you do a 1-to-1 mode, that means usually very often people use like the RC-100 and a single bot. That means you have 1-to-1 mode. No worry about setting different channel because the system knows it does that stuff correctly. When you do broadcast, the system like we have here is USB 2 serial USB 2 or COM port. By default, this ZigBee2 serial will go to default to channel 1. And when it is channel 1, it works best for CM5 because that's what the CM5 is set up for. However, for not nowadays, when you use these things, you probably have CM510, CM530. They use channel 4. And this matters when you're in broadcast mode. So that's something important. And the only way you can do, one of the way to be exact, one of the way to do channel 4 in broadcast mode is to remove an R7 resistor on the ZigBee2 serial board. You probably cannot see through the video. So making a blow up here, you see R7. It used to be something like a little piece, like a resistor here, like on R6 and R5. But then you just use a clipper and clip it off. Obviously, once you remove R7, it's removed unless you resolder. This ZigBee2 serial, after you remove R7, essentially is set up on channel 4 only. You cannot use it back to channel 1 for CM5. So keep that in mind. Once you connect it, you can use the manager tool, and I'm just going through different slide here to give you an idea. We'll do an actual demo coming up soon. Once you hook your ROBOTIS manager, you hook it up. You can use a ZigBee setting, and you can hook it up. And then you hook it up. You can have the remote ID here. You can write in a specific ID for the ZigBee110A or the ZigBee100, another ZigBee100. You can modify it. Or you can go to broadcast mode, and then you are in broadcast mode. And then whether you wait mode or not wait mode. I found out wait mode is not very useful for within the ROBOTIS system. Sometime I found out that the ZigBee2 serial US2 dynamic, so somehow like the first level USB port in the back of the PC. Once connected, you can do many things. You can put in your own data here, and you can put send, and you can see how the send data is. In the example, I'm going to show you the robot here. actually receive the data and send it back, or it can send it back itself too, and you can see it here. Or you can click on RC100 and then the virtual RC100 here. You can click this button if you want to. That's another way to do it. And so it's just like you're in task program. So this thing again. The broadcast mode, finally, one go before we leave all this, is you can set up the broadcast mode inside the manager. Of course, you probably know by now, inside of your TSK program. You can also set that remote control ID. You go to 65535. You can do that inside the task program also. And this is a TestZigBee program, which should be included in the posting. And it's a simple test program that I download to this guy and this guy. Both of these ZigBee-110A are already set up for broadcasting only. So what does this TestZigBee program, task program do? Essentially, you can see the endless loop. It waits 1/8 of a second, mainly because the loop is going through fast, very fast. So sometimes you need a little bit of delay each time so that the messages can catch up with each other, essentially. When you full blast, you can do that Visual C also. But this program kind of small, so you need a little bit of wait time. So you check if the remote can arrive, the flag is true. That means the robot receives something, pick it up, save to data receive parameter. If not, just set 0 to that parameter data receive. So once you receive something, you TXD, that means you send it back out to the PC, essentially the same data that you receive. So essentially, whatever the bot receives, it's sent back one time. If not, it's sent 0 only. So most time it's sent 0, essentially. Also, have a piece of if-else if group. If somehow on the robot itself, if I put the up, down, left, and right button, the bot will transmit a certain signal. So if I push up, it will send the number 2. If I push D, send number 4. If I push left, it send 8. R send 16. And that's the extent of the loop code. Okay. So let's get on with it. Let's see RoboTis Manager. And right now, RoboTis Manager have a USB port. You go to USB to the Mixo, SIG to serial, and a ZigBee-100 daughter board there. Okay, so I'll leave it here for the moment. Let me get closer so you can see. So first, let's find which COM port I'm on. Okay, I probably come on COM 10 this time. And normally when you RoboTis Manager, you click on this one, right, to connect to your robot. You don't do it this time. You don't connect here. You go over to SIG to serial management, left click on it. So this will come up on. So check this COM 10 set up at 57.600 and all of that. So first we need to check the ZigBee setting. And this is a trick I need to show you. In order to click on ZigBee, you left click on ZigBee and this one up. I know the menu say, after clicking the OK button, push the reset button on ZIG to 0 within 2 seconds. I found it more reliable, and this is the reset button. I found out it's more reliable to push the reset button first, click OK, and then release it. Okay, because I found out that everything tend to be synchronized on the release of the reset button, not when you push it down. It took some figure out to do that, to make it reliable each time. So now you can see it was in broadcast mode. If I had it to want to go to 1-to-1, and let's say my other ZigBee 110A address was 11.084, and then I would put it here. You see it change, but I want broadcast mode this time, so I click on broadcast. You see everything changed. I'm done then. Okay, so now let's go over to these guys. So I will keep this one here a little bit down, maybe in the line of sight here. So let's say I'm going to start with this gun first. So I turn it on. It's in play mode. Push play. So the program is running now. Okay, and you notice what? It starts sending data back to the PC. It's at 0000 here very often. Okay. So right now they're communicating. So let's say I want to send 255. This is from the PC side. If I click on send, you need to watch out the receive here. You're going to see it brought back 255 one time. See that 255 one time, and then it's all 0 because of the endless loop. So let me push 255 again. You see it repeating here one time, receive back. Okay. Or you can use the RC-100. And let's pull it in. So you can push up, it's send 1, right, send 8, 5, send 256, 1 is sending 16. If you hold it, you see you send 128, 1 is continuously. 6, it will send 512 completely coming back. Now as soon as you relieve, it gives 0. Okay. So essentially that's the basic of the stuff. Let's see now what happened now I push up button here on the robot. You see it send 2. So every time I push 2, I push left. It's sending over 8. You should see it in the receive data, and then it's set to 0. That sends 16. Every time I push it, it sends 16. So that's a little piece of code that essentially shows that. Now, the interesting part what happened is this bot here also on broadcast, and it had the same program, and it's on broadcast. So I'm going to turn it on, and then I push start on it, and it's run the program. So right now, this is interesting. The PC is broadcasting everything. It receive and send everything out. This one is receive and send everything out. This one receive and send everything out too. So that's 3 of them broadcasting together now. And this is getting interesting. So let's say I put in 999. If you remember previously, anytime I send one, it repeated one time and then it stopped. Now this is interesting. Send. And you see it sent. So there's a bunch of 999 one time. Let's do it again. Now it catch it, and you see keep on sending 999, even though I push it only one time because it's broadcasting, so everybody receive it, and then they start repeating. Everybody receive it, so you see it for a while it's all 999 until after a while the traffic clear looks like, and then it becomes 0 again. Oops, okay. So it send quite a bit of time for a while until it's clear. Oh, this time around it catch a lot. So that keep on bouncing around the same entry to each other. And that's the situation. So that's essentially it caught up in the message. So doing broadcast, you can see that if you just send a signal only, it's kind of hard. You have to have somehow create a message protocol. So this one knows the message for it. This one knows the message for it. So somehow you have to code the signal that finally clears out now. So let's see. 256. Here we go. It got caught and then it kind of clear out again. Hopefully. Good. So mismatch. Sometimes it catch on for a long time. Then I finally 0. So I send it again. Okay, that's it.